Okay, so very good afternoon. Okay, so in the morning session, actually, we have covered all the theory topics regarding to the Arduino. What is Arduino? How many pins are there? And how many I/O lines are there? Then how many analog inputs it accepts? So that all things we have covered. Theory, it is all regarding theory session. But today, the second session is totally practical session. But before starting practical session, actually, we'll talk about what is our environment that we are using for programming. Okay, so we are using the Arduino software. We're using Arduino software. So I will start my presentation. Okay, so Arduino program development. So it is totally based on the C++, as we have already discussed. The last question I have answered as it uses the C++ language for programming, but actually it is not a fully C++ language. Background is a C++, but front end is totally been modified depending on the user. The function they have modified for the user, that is the function should be a very meaningful function, and using that function, actually the background detail, that is how that IO pins works and how actually background things are happened, that is not concerned with the user. User will do whatever they have to do. For example, if the user wants to send a 0 to one of the pin, then there is a function design name as a digital write function. So we must know only this function. We don't have to deal with the language. So we'll see first the structure. What is the structure of that program, and then we'll start moving towards the programming session. Okay. So the programs here, the programs are called as sketches. Okay. So generally, whenever we start with any embedded programming, we call it program. But here in Arduino, actually, it called as a sketch. The sketches needed two functions. Okay, it always needed two functions. So every sketch must have two functions. Because program, if you talk about the program, I mean, if you say that I'm doing a program, your program should have the main function inside it. But in this Arduino program, actually, there is no main function is there. Actually, main function is there, but it is in a background. In the background, actually, main function call that setup and loop function. Okay. So in a front end, actually, only two functions we have to write down, setup and loop. These are not only the two functions, but these two functions are the minimum two functions that we have to write. So it needed the two functions, setup and the loop. So we'll see what doing by setup and loop. What is the need of this? So setup function is the very first function to be called by your bootloader. Okay, so we know that your Arduino IC, that is your Atmega 328P, this IC is having the inbuilt bootloader. Okay, it is having the bootloader inside it. So that bootloader, whenever you upload your program, and when you execute the program, that bootloader will call the setup function. Bootloader will call setup function first. Firstly, it will call setup function, and it will be called only once. First and once, very important one. It will be called first and once. Second one, after the setup function has completed a task, the second function is called as a loop function. So when the setup has completed its execution, the loop function will be called, but the loop function will be called again and again and again and again. So it will call over and over until the power is lost or the new sketch is loaded. Getting? So setup will be called only first and once, and the loop will be called over and over. So what we will write inside setup and what we will write the loop function inside the loop function. So whatever the statement that we want to execute initially, and that it should be executed only once, the same statement we are putting into the setup function, and the statement that we want to repeatedly execute, that statement we are putting into the loop function. Getting? So the loop function is nothing but your while one loop. It is just like a while one loop that we are writing into your embedded programming. So it is an infinite time the loop function will be called. So whatever you are writing inside the loop function, it will be continuously execute again and again and again and again. No need to put the while one into the loop, because loop will be called infinite time by the main function. The main function is present in your bootloader actually. Okay, so until the power is lost, the loop function will be executed again and again and again. So getting these two functions, setup and loop, out of this two function, actually, suppose we want to write our own function, then we can write the third function, fourth function, fifth function, depending on our requirement. Okay, so we can add our main function before the setup, in between the setup and loop, or after the loop. Anywhere we can add our user defined function. Okay. So here we will talk about the how to start with the programming. So before starting the programming, actually, let me clear that you can do the program, you can do the Arduino programming in an offline mode also or in an online mode also. Offline mode means you should first download your IDE, Arduino IDE from the arduino.cc. So I will share you where have to go there. So this is my website arduino.cc. So in that arduino.cc, actually there are the lots of stuffs are there. You can go through this. There are different new projects they are always launching. There is touch less, do more challenges. Okay, some challenges are also there, but we have to look here in the software. We need to click on the download buttons. Okay, so go to the arduino.cc, go to software and go to the download button. So when you click on the download button, actually this window will be appear. This window will be appear. So firstly, this Arduino web editor. Now what is this web editor? The web editor is the online version of the Arduino IDE. So you don't have the computer with you and if you want to do a programming. Okay, if you don't have the Arduino IDE installed in your computer and if you want to do a programming, okay, you don't have the admin access. So just open the web editor. This is the web editor. So in that web editor, actually, you can create a new sketch. When new sketch is created, this Arduino file will be created, and here you can write your program. And after writing your program, actually, you can upload your program at your, so here you have to select your board. You have to select the board. Suppose I have to select the board as a Arduino Uno. And after selecting the board, you just have to press OK. And when you want to upload it, if the board is connected, then you can directly upload it from here itself. Getting? So directly you can start doing your programming online itself, but I prefer the offline version. So for that offline version, actually, you need to go below and here download the Arduino IDE. This is the tab that you have to visit here. The latest version is 1.8.13. This is the latest stable version, but you can have the 1.9 also. That is a beta version is there, beta version. Okay. So beta version is not, it is only for the experimental purpose, but I prefer that stable version 1.8.13. Now this Arduino software is for all the operating system. Depending on which operating system you are using, actually you have to click it here. For example, if you are using Windows 7 or Windows 8, just you click on here, Windows installer. If you are using Windows 8.1 or 10, then you require Windows app. Suppose if you are using Mac OS, like I'm using here Mac OS, so you need to click here Mac OS X, and depending on what Linux that you are using, you have to click on here itself. Okay, so Arduino supports maximum all the operating system, and you just need to download it. When you click on when you click on this button, actually the downloading is started, and you just have to wait. The exe file in a Windows or the DMG file in your Mac OS will be downloaded, and you just have to install, very similar like your other software that you are installing. Okay, so installation part I'm not taking because it's a very simple installation. Just click on the next button, select the path on which you have to install the Arduino, and then after that click on the next and then finish, and very simple installation will be there. Okay, so are you getting this point? Are you getting this point? Arduino installation. If you are getting this point, just type yes in the chat box. Okay, so if you have the computer with you, your own computer or a college computer, just you need to go there, arduino.cc, just visit this website, download the appropriate software, appropriate operating system software, and install it. This is your today's assignment. Okay, now next one we'll see the our PPT. Okay. Okay, so very first thing that we have done, very first step we have done, download and install the Arduino IDE. We have done already. Now the next one is the connect the board to your computer via USB cable. Okay, so now firstly you need to connect your cable via the USB cable, and the USB cable, the another end of the USB cable should be connected to your Arduino. Okay, so I have already connected here. Just stopping my recording. You can see here, this is my USB cable. This is my USB cable. The one end of the USB cable goes to the USB port of my computer, and the second end, that is your D type connector, that is going to my Arduino. Okay, so here I am powering on this Arduino by the USB cable itself. Okay, so I don't require the adapter here, I don't require the battery here. Okay, so USB is enough to power up this board here. Okay, so what I'm doing, I'm inserting this board USB cable into my computer. Now you can see here the light is on here. Okay, so here this is the power light. We already discussed in the morning session. This is the power light, and this is the what is the that LED is blinking, that is your pin number 13. This LED is connected to pin number 13. I think this board having the already blink LED program, so that's why this is a testing program, and every your Arduino board is having it. Okay, so when you first connect it, okay, so that's why this is blinking here, so it means that this board is correct. Okay, or otherwise you can also test by yourself again. If this is not working, if this LED is not blinking, then you can test it yourself. We will see that also. Okay, so this is the connection that you have to make here. The remaining connection actually I will be covered. Okay, so here when you connect the board, actually if the drivers are non-installed, if the drivers is not installed, then it asks to install the driver. And what is the driver? The driver is for the USB to UART converter. Okay, so this Arduino is having the inbuilt USB to UART converter. Okay, so this is the USB to UART converter. Let me again. Okay, so this is the just below that LED, actually just below the LED there is a square IC is there, SMD IC. This square SMD IC is nothing but your USB to UART converter. Okay, this UART converter, that is serial converter, USB to serial converter. Okay, so this is the IC, and to use this IC actually you require to install the drivers for it. Okay, so first you need to install the driver, because already my computer is having the driver installed. But when you connect this Arduino at the first time at your end, the driver has to be installed by yourself. It is very simple installation. It will ask the prompt, continue anyway, install driver, just 3 or 4 times you have to click there, and all the drivers is installed. It hardly requires 5 to 10 minutes to install all the drivers. Okay, so we have installed the drivers. Now next one is the next step is we have to launch the Arduino IDE. Now how to launch any software, we already know that. just double click on that Arduino ID, and your Arduino ID will be launched there. The next step is the select your board. Yeah, board has to be selected because we already seen in the morning session that there are different types of boards available for the Arduino. Okay, so Arduino, you know that you are using Arduino Mega, you are using Arduino, which Arduino you are using, Mini, you know, which Arduino you are using, Node MCU, which you are using, that you have to select your board. The next step is you have to select the serial port. Okay, so you have installed the drivers. When the drivers is installed for the USB to UART converter, your computer will give you one serial port. Okay, generally in your Windows computer there is known as a COM port, COM1, COM2, COM3, COM. COM1, COM2, COM3 port actually you are getting. COM1 is the by default you are getting from COM2, COM3, COM4. Okay, so any port you can get it here depending on what port is already been allocated. The free port is allocated to your hardware. You have to select that particular board. Now how to check that that particular port is for your Arduino, you know. So for that purpose you have to check it by removing that cable. When you remove the cable, that serial port is gone. When you again insert it, your serial port is there. So you have to check it which port number is there. Okay, and you have to select that port before the uploading your program. Next one is the open the blink example or write by yourself, and next one upload the program. Whatever the program that you are writing, you have to upload it. So these are the steps that you have to carry out for the first program. So this is the same thing that we have done. Now next one is the software introduction, the IDE introduction. So very first one is the sketch name. So in the middle one there is a name of the sketch that it is being appear. The by default the name is sketch underscore and the month name and the date. Okay, so this is the format. But when you save your program, actually the same name will be appeared there. For example, if you save your program with the blink, then there is a blink will be appeared here. So whatever the sketch name you will be appeared there. The next one is the Arduino 1.8.2. This is the version of your Arduino that you are using. The next one is the toolbar. Now the toolbar is the graphical toolbar. By using these buttons, actually you can directly do the different tasks. Like first one is the okay, so this one, sorry, this one, the first one is the verify. First one is verify. Verify is very similar like your compile. Okay, compile. If you want to compile your program, click on the first button. Second button is the upload button. Suppose if you have successfully compiled and if you want to upload your program to your Arduino board, you have to click on the second one. Next one is the new sketch. If you want to create a new sketch, then it is a new sketch, and it is, I think, undo. Okay, it is undo and redo buttons. Okay, but if you don't know this, just just go into that buttons. There is a prompt is there. That prompt will show that what is the purpose of that button. Then in the new version, actually these buttons can be vary. Now menu bar is also there, just like your all the software is having the menu. This software is also having the menu like file, edit, sketch and tools. We'll see one by one what is that menu contains. Just like file menu contains a new, open, save as, print, like that, properties, examples. Edit contains a cut, copy, paste, this like that. Sketch contains the sketch related operations like new sketch and compile and that. Tools contain the different tools like serial monitor and that. Okay, help contains the help. Okay. The next one is the editor window. In the editor window, actually, where it is the area where actually we will write our program. When you open your new sketch, actually, by default the two function is being appeared here. Two function is by default appear, setup function and loop function, and we know that what is the setup and loop function. In a setup function, we will write down the things that we need to write that we want to run only once and first and once. And in a loop function, actually we'll write the code which will want to run repeatedly. Okay. So this is the editor window. The next one is the console window, where actually all the errors you can see there, all the warning messages, all the console related operation you can see here. The last one is the board connected. Here you can see the which board you have selected and what is the COM port you have selected. Okay, so it is very simple. And the last one is serial monitor at the right hand side upper corner. Serial monitor is there. Generally, when you do the serial communication program, you can see there serial monitor is this is the software that we are sending the data, or always we are receiving the serial data from your Arduino. Yes, getting this. Okay, so verify, upload, new, open and save. Yeah, this is the open and save button. Open and save. Now this is the third step. Select the board. You have to click on the tools and then click on the boards and Arduino. Actually this is only for the presentation, but we are also doing the same in the software itself. The next one is the serial COM port. You have to go to the tools, port and COM6. Yeah, actually it is COM6, but depending on your connection, your computer, it might be it might be COM3, COM4, COM20, anything COM, it can be there. Okay, so we'll start with the Arduino software and then we'll move towards the presentation. Okay, is it visible or should I increase the font? Yeah, is it visible? Just give me the feedback. Is it visible? Just use chat window. Yes. Or okay. So here when you open the new sketch, actually the two function is already being there. You can see here I have not saved the sketch, so that's why it is sketch underscore September 21B. Okay, so it is B. So here two functions are there, setup and loop function. This is the comment window, comment double slash. We know that in C++ double slash represents a single line comment. We can remove this comment here. This also put your main code to run repeatedly. We can also remove this comment. Actually comment is required when you want to explain your code. When you want to explain your code, comment is required, but here I'm removing that code. Now first thing is I have to save this program. Okay, so first Control S, I have to go there, file and save, or directly file and save, Control S. When you click on the Control S, so it will ask for the name. So I'm saving the name as blink underscore NHCE. Okay, so my first program blink underscore. You can see here the name has changed here, blink underscore NHCE, and here blink underscore NHCE. This is the name of my file also. Okay, my INO file is also having the name blink underscore NHCE. Now the program that we need to do is your test program. Very first program is a test program, that is your blink LED program. This is the program for your embedded system as a hello world program. In your C, C++ or Java, actually you are always doing, or you are always checking the compiler with the hello world. Okay, so here we are checking your compiler and the hardware with the blink LED. So what we need to do here, we need to blink the LED, but the LED is connected or not. Your built-in LED is also there, built-in LED, and built-in LED is connected to pin number 13. Okay, so we have to blink this LED which is connected to pin number 13. Okay, so pin number 13 is the IO port. It is the input output port. it is an input output port. So it can be used for input or it can be used for output purpose. So we need to define that I have to use this pin number 13 for the output purpose. So we need to set the mode of the pin. We need to set the mode of the pin. So for setting the mode of the pin, I'm using the function name as a pin mode function. Okay, so we have to call the function called the pin mode function. Pin mode function, generally this function is used to set the mode of the particular pin. Make sure that here there is no space in between pin and mode, and M should be capital. This is a general syntax of writing the or giving the function name. Okay, it is a IEEE syntax. P should be small, M should be capital, pin mode. Okay, so it takes the some arguments. This function is called, we are calling the function and we have to give some arguments. The arguments are the which pin number 13. So on which pin number you have to set the mode. Pin number 13, we have to set the mode. Okay, what is the mode that you want to set to the pin number 13? The pin number 13 has to be set as an output mode. Okay, so the meaning of this pin mode 13 is set pin 30 as output pin. Okay, set the pin number 13 as out. Very simple definition to set the pin number, any pin as an output pin. Very simple. Okay, so my pin number 13 I can use as output. Now we cannot use here pin number 13 as an input because it is either or. You can use the pin number 13 as an input, either you can use the pin number 13 as an output. So 13 is an output, we have used it. Now next one is the, we need to blink the LED which is connected to pin number 13. Now what do you mean by blink? Blink is nothing but LED should be on, LED should be on. Now how to on the LED, how to off the LED? Okay, so if you know the connection of the LED, then we will again go back to the, yes, we can go here. Okay, so here actually the LED is connected externally, but the same connection you can think about for the internally. Okay, so LED is connected here, but how the LED is connected? The anode terminal of your LED, the anode terminal of your LED is connected to pin number 13, and through the register it is connected to the cathode terminal, is connected to the ground. We know that here what is the working of LED, anode and cathode, positive and negative terminal. Positive should be connected to VCC, cathode should be connected to the negative terminal. Okay, so if it is connected to your anode is connected to pin number 13, and if I'm making the pin number 13 as a 1, so it means that 1 means 5 volt is available to pin number 13. Now how 5 volt is available? Because it is a digital pin. In a digital, actually there are only 2 levels are there. First level is the high level, second one is the low level. High level means 5 volt and the low level means 0 volt, that's your ground. Okay, so pin number 13 if I'm making as a high, then it is a pin number 13, it is a having the 5 volt power supply. So 5 volt power supply is connected to anode and cathode is connected to the ground. In series actually there is a resistor is connected. You can use 100 ohm resistor, 220 ohm resistor or 330 ohm resistor. Okay, all are valid. Okay, so here the connection is internally made like that, and if you want to on the LED, pin number 13 should be made as a 1. If you want to off the LED, pin number 13 should be made as a 0. If pin number 13 is made as a 0, the anode terminal is connected to ground, cathode is also connected to ground, so LED is off. When the LED is off, then the LED remains. LED, we can say that here LED is off and we want to make it as a on, Anode terminal is connected to VCC. Pin number 13 is VCC. You are making a pin number 13 as a 1. So LED is on. So what is blinking effect? Blinking effect is nothing but you are firstly switch on the LED. First switch on the LED, and then next one is switch off the LED. So how to switch on the LED? So for switch on the LED, actually you have to make the pin number 13. You have to make pin number 13 is equal to 1. And to switch off the LED, you have to make pin number 13 is equal to 0. But how to make it? How to make the pin number 13 as a 1 and how to make the pin number 13 as a 0? To make the pin number 13 as a 1, actually we are using the inbuilt function named as a digital write function. Okay, so digital write function generally used to write the digital 1 or 0 to a particular pin. Okay, so it again takes the argument. So arguments are nothing but your which pin you have to write. Pin number 13. On pin number 13 we have to write digitally, but what you have to write? You have to write high. You have to write high here. Okay, instead of high you can simply use 1 here. 1 is nothing but your high. Okay, so or instead of that you can use high. Next, you have to make the pin number 13 as a 0. But how to make the pin number 13 as a 0? It's very simple. Use the same statement, digital write function, call the digital write function, pin number 13, and you have to send low there. So here pin number 13 is high, pin number 13 is low. So in and this, how many times the statement get executed? Infinite time. If it is executing infinite time, then you can say that the LED will blink infinite time. But here, what is the blink rate here? The blink rate is very fast here, because to execute a one command, actually microcontroller requires the 1 microsecond only. Okay, so 1 microsecond blink, it means that for this statement 1 microsecond, for this statement 1 microsecond. It means that for 1 microsecond it is on, for 1 microsecond it is off. So when you run this program, actually you are not able to see that blink. Actually the LED will blink, but human eyes cannot detect that blink, because our persistence of vision, due to the persistence of vision, actually we are not able to detect the blink. Okay, so to detect the blink, actually what we do there, we will put the delay in between the high and or low. Okay, so delay is delay 1000. Now what is this delay 1000? The delay 1000 is nothing but it produces the delay of 1000 milliseconds. So that is equal to 1 second. That is equal to 1 second. Okay, so it is a delay of 1 second. Again off and again delay of 1 second. Okay, so what we have done here, we have written a program here which will able to blink the LED connected to pin number 13, high and low. Because I have not connected the external LED, the inbuilt LED I have to test it here. Okay, so just I have made it program. Now next one is the I have to compile it. So when you are compiling your program, just click on the verify button. When you click on the verify button, just wait it here. But before verifying the button, you should make the selection of the board and the port itself. Okay, so I will show you. First click on the tools, go to the board, go to the Arduino AVR boards. Now this comes in a new version of the Arduino. Previously that Arduino is directly here, the list is there, but now they have separated this board in a 2 variants, Arduino AVR board and the ESP8266. Generally this ESP8266 are used for the IoT purpose. Okay, so Arduino AVR boards, and the next one is the which Arduino board you are using. I'm selecting as a Arduino Genuino. Okay, so here board I have selected. Next one is the selecting the COM port. Okay, so here COM port, there are two COM ports. First one is Bluetooth. Okay, my computer is having the Bluetooth, so that's why it is showing that port. And here the new port I have, it is being appear when I connect my board. The name is /dev/cu.usb modem 414101. In Windows, if my computer is having Windows operating system, then there it might appear that COM3 or COM4 there. Okay, so this is the two selection you have to carry it out before compiling your program. If you are not selecting this board and port, then compiler give the error first. So verify button, I am again clicking the verify button. If your program is not having error, then it will successfully show the output as a done compiling, and it will show sketch using 924 bytes, maximum is this, global variable as this. Okay, so these are the one notification from the compilation. Getting? Now next one is the upload. Now uploading is again very easy. Just you need to click the upload button. No need to click on the reset button. Directly click on the upload button. When you click on the upload button, you can see here the serial LED will be blink for some times. And what is our program? Program is the blink the pin number 13. Now pin number 13, that is the LED. That LED is start blinking there. LED start blinking. You can see here in my video actually the LED start blinking. Now we can change the program and we can see what is the difference. What is the change? Instead of putting the 1 second delay, I am putting the 0.5 second delay. Again compiling. After compilation, now you can see here when you compile, actually when you upload, the LED is not glowing there, and continuously that serial, and you can see here the output. My blinking rate of my pin number 13 is now becomes more. Okay, so likewise actually you can play with this program. You can first on day first only you have to play with the LEDs only. On second day onwards actually you can start by exploring the more sensors, because this digital write and this delay is a very important things. Okay, so now what we can do here, we can change. If I'm changing here the pin num, so what the changes I need to do here? So every time, suppose I don't want to use the built-in LED, I want to connect the external LED. So external LED, suppose I am connecting to pin number 8. Okay, so 3 changes I have to do here. 3 changes. Pin number 8, pin mode 8, pin digital write 8, digital write 8. Okay, 3 changes. So instead of that, what we can do, we can create one variable, integer LED is equal to 8, and instead of using 8 I can use this variable LED and LED, and better to put this variable as a const variable. Okay, so because if you are trying to change this LED here itself, then it will give the error. Okay, so if anyone is changing this global variable, then it will show the error. Okay, because LED is connected to pin number 8, so it should be 8 here. So constant variable I have created, and the same variable I have used in my program actually. Okay, so if I want to execute this program, the compilation and the uploading is very similar, but what is the next thing that we need to do? Can anyone tell me? Can anyone tell me what we need to do here? Suppose if I want to connect the LED to pin number 8, then what we require? What is the required things? Hmm? So what we require? We already have downloaded the program. Now next thing is the hardware. Now hardware is the Arduino is we are having. The next one, what we need? We require the breadboard. We require the breadboard. Yes, we require the breadboard. What is the next thing that we require? We require the LED. Okay, we require LED. Okay, what is the next thing that we require? We require the register. Getting? So these three things we require. LED we require, register we require, and the breadboard we require. Now how to connect it? How to connect it? Now the connection of this LED and the register is shown on the slide. If you have the board with you, you can make a connection. Now, right now, I'm making the connection. Now, while making the connection of the LED, make sure that you should know what is the anode terminal of LED and what is the cathode terminal of LED. Anode terminal, you can simply identify the long terminal of your LED is the anode and the short terminal is the cathode terminal. Okay, so anode is connected to pin number 8 and the cathode is connected to ground through the register, or even you can replace the position of your register, that is you can also connect the register in between the anode and the pin number 8 also. Okay, so as shown in your diagram actually. Okay, so what is the next thing we require? I have done the connection. You can see here I have done the connection. This is my anode, this terminal is the anode, this is the cathode, and the cathode is connected to the one of the terminal of your register. Now these are the two terminal that should be connected to your Arduino. This terminal I'm connecting to ground. Okay, where is the ground terminal? We know that. Okay, but now the next anode terminal, this is my anode terminal, and it should be connected to the pin number 8 of your Arduino pin. So to connection, what we require this type of pins. These pins are called as a breadboard wires. Okay, and the type of these breadboard wires are the male to male connector. It's called as a male to male connectors. Okay, so this male to male connector I require the two male to male connectors. So I have removed that male to male connectors. Now next one is this is my ground terminal, and the next one, this is my anode terminal. Okay, so red one is my anode terminal and your gray one is your cathode terminal or the ground terminal. Getting? So I have done the connection. Now I know that a red terminal should be connected to pin number 8 and this pin, that is your gray pin, should be connected to ground terminal of your LED. So I am making the connection here. I'm going to show you here. Here I have made the connection. Pin number 8. You can see here the connection first. Pin number on to pin number 8 actually. Pin number 8 I have connected my anode terminal, and the ground is the power lines, that is your ground I have connected here, and you can see here the magic here. Now your LED start blinking. Now the pin number 8 actually I have connected, I have programmed the pin number 8. So here you can program any digital IO pins. Okay, so this is the single LED that we have connected. Now the next one is the okay. So this is the program that we have already been discussed. This is the steps. This actually PPT I'm going to share with you today itself. The next one is this is the output. You can see the output by showing the sorry. Where is that? Okay, so you can see the output. If your this is a mini breadboard actually. The cost of mini breadboard is nearly up to the 60 to 70 rupees, and for bigger breadboard is having the cost of 110 rupees. So everyone getting the point that I want to discuss or I want to deliver with you. LED blinking. If you have the hardware with you, are you able to do? Can you able to do this? Just type yes. If you are getting all this point, just type yes. Yeah. Just type S if you are getting all this point, just so that I can move forward. Okay. Yes, yes. Now the next one is the two LED interfacing. Okay, so why I'm taking these points actually, because if you have the strong basics, then you can move toward the advanced easily. Okay, so firstly we have to play with these LEDs. Okay, LEDs interfacing and that. So it will actually make a hands-on on the hardware as well as hands-on on the software programming part itself. Okay. Okay, so two LED interfacing. Now in a two LED interfacing, what we need to do, we have to repeat the same procedure that we have done. The first LED, second LED, we require the two registers. We require two registers. But the one thing is common is here, the ground terminal we need here, ground terminal. The ground terminal actually, it should be con because we require the two grounds here. Two ground is required. One cathode is connected, first LED cathode, and the second LED cathode should be connected to ground. Okay, so rather connecting these two ground to the Arduino board, what we are doing, we are putting this ground into the one of the horizontal row. We are putting this into the one of the row of your breadboard. Now this all the horizontal lines or the row is the ground. Now we can have the multiple grounds available here. Now the ground of the first LED and the ground of the second LED is connected to the breadboard itself. Now next one is the anode terminal of your first LED and second LED. You can select any pin, pin number 8, pin number 9. You can select any pin and you have to connect that ground there itself. Okay, so very simple. Now next one is program. Now what is program? The program is again easy. Previously actually we have used the one LED only, so that's why we have done the in a setup function. Actually we have set the mode for the only one pin mode 13 comma output, or pin mode 8 comma output. So instead of this we want to use here two pins. Simple. So use the two pin mode function. Pin mode 12 comma output, pin mode 13 comma output. So whatever the pins that you are using for LED anode, that you have to mention here. So pin mode 12 comma output, pin mode 13 comma output. This is comes in a setup only. Next one is the loop. In a loop again we have to blink the both LED at a time. So if we want to blink the both LED at a time, then before the delay occurs, the both LED should be on, then delay, then two LED should be off, then delay. So similarly you can see here the two LEDs are continuously blink now. Okay, so I can show you with this connection. Okay, I am making the connection here itself. Give me 1 minute only. Okay, one more lines I require. I'm using the pin number 9. Pin number 9 as a second LED. Okay, so you can see here I have done my connection. The one LED, which is already I have programmed pin number 8, which is blinking, but pin number 9 I have not programmed, so it is not blink. But the connection I have made it here. Pin number 9 is connected to anode of the second LED. Okay, so let's check the program by doing the programming. Okay, so yeah, we'll also discuss that alternate blink. But before starting, let me complete this first. LED 1 and LED 2. LED 2 is connected to pin number 9. Yes, pin mode LED 1 comma output, and just copy this and paste it at another line and make it as a LED 2. Pin mode LED 2 comma output. Okay, next one is digital write LED 1 comma high and LED 2 comma high. Okay, the next one is again copy, paste it here, LED 1 comma high, LED 2 comma high. Okay, and I have done my program, uploading my program. It is still compiling and it is uploading, and you can see here the output. You can see here the output. I'm stopping this share. Okay, you can see the both LEDs start blinking now. Okay, both LEDs start blinking. Okay, so Shubhra is asking that alternate blinking. So we'll try that alternate blinking also. We'll try the alternate blinking. So what done by alternate blinking? Alternate blinking means when the red LED is on, the blue LED is be off. Okay, so LED 1 is the red LED and it is the blue LED. Okay, so when red LED is on, blue LED is off. Okay, and when red LED is off, blue LED is on. Very simple. So I have done my program and we can see the output. Okay, it's still compiling and it is uploading. Now you can see the output. I'm again stopping share. Okay, you can see the output now. The LED is now blinking alternately. So are you getting? So LED start blinking. Yes. Okay, so similarly, actually, we can again increase the LED. We can increase the LED, 2 LED, 3 LED, 4 LED. So for your students, actually, you can give the assignment such that connect the 8 LEDs. Okay, you can connect the assignment should be connect the 8 LEDs at a time and give the running LED effect. Do the running LED effect, or the alternate, first try with the alternate LED and then after that with the running LED effect. Okay, so these are some assignment actually I am giving to the students. Interface 2 LED with Arduino to pin number 2 and 3 respectively. Write a program to toggle the LED with a delay of 0.5 second. Then 4 LED, then 3 LED, two different, and do somewhat toggle LED, running LED, like that. Okay, so can anybody tell me what is the running LED? What is my running LED? Just unmute yourself and tell me what do my running LED. Yes, I will share the PPT. Okay. So what is the running LED? Can anybody tell me what do my running LED? Yes. Or you can use your chat box to type the answer. Continuously on. Yeah, is it correct? Continuously on. Chasing, yes, correct. Chasing LED. Chasing LED means if there are three LEDs are there, the effect should be first LED. When the first LED is on, second and third is off. When the second LED is on, first and third is off. When third LED is on, then first and second is off. Okay, so we'll try that one also. We'll try that one also. Okay, so I have connected here the three LEDs. Now it is a two LEDs program I have done only. Okay, so let's do the three LED program. Okay, so can you guide me? Const int LED 3 is equal to, I have connected to pin number 10. Yes, pin number 10 I have connected. Now what is the next move? The next move is pin mode LED comma output. Yeah, done. I'm removing this. Okay, now next one is, okay, so what is the first condition? When first LED is on, second and third is off. Okay, okay, now next one, when second LED is on, first and third is off. Okay, and again I have to put one more condition here. When third is on, just make the third on high, first and second should be low. Getting? First on, second, third off. Second on, first, third off. Third on, first, third off there. Okay, so just uploading this program and just see the output. Okay, I'm stopping my, and you can see the output here. Okay, now is it chasing LED? Is it chasing LED? Yes. First on, second on, third on. First on, second on, third on. First on, second on, third on. Now it is very important that when your first is on, second and third is off. Okay, so that is the thing that you have to explain with your student. That is, everything matters here. If you are only on the first one and then second on, then third on, the first is still on. When the third is on, first and second is on, so it is not a blink effect, running LED effect or chasing LED effect. So every condition should be, you have to put there. Okay, so or otherwise actually the same program I can do in a different way. Actually, if this program is of the 8 LED program, then now there are the, this way of programming is very long here. So instead of that, I can do the program in a different manner like that. Okay, so just look at here. So for integer I is equal to 8, I is less than or equal to 10, I plus plus. Okay, so I'm using the for loop here. Okay, if you are compatible with the C language, then you can easily use this. Integer I equal to 8. What is I? I is the LED number. Okay, I is your port 8, 8, 8, 9, 10. These are the port number. Now what I have to do? First I have to on the 8. So digital write 8 comma high. Okay, I have to put it here. Okay, 8 comma high. Okay, so first LED is on. Okay, then after that on, we have to put delay. We have to put delay. The delay is, suppose 500 is the delay, that is 0.5 second. and then after that all the LEDs off. I'm making the all LED off. Okay, I'm making all LED off. That is 9 comma low, and then digital write, then 10 comma low, and then again digital write, then 8 comma low. Okay, so this should be 8, this should be 9, and this should be 10 comma low. Okay, but this 8 is now varied here. Now whatever the 8 I have put it here, I am varying it with the I here. So firstly, the 8 number I is equal to 8. So 8 will be high, and then after 500 millisecond all is low. Then after that, then after 9 will be high, all will be low. 10 will be high, all will be low. Like that. We will see the output. Is it works or not? We will see the output. This is my logic. You can design your logic also. Okay, you can see the output. I have already uploaded the program. I have uploaded the program. The same output you are getting here. Same output. Yes. So these are the things that you have to told to your students. That is, play with these LEDs only. 8 LEDs or 4 LEDs. 4 LEDs enough actually. If the students go for the 8 LEDs, then it is a very good. Some students are going for the 16 LEDs also. Okay, not 16, 12 LEDs, because 12 IOs we can use maximally here. Yes, are you getting the point? Yeah, just type yes, and I just type yes. Yeah, so try yourself. I'm going to share this program, or this program is available actually. No, it is not available in PPT, but you have to try it by yourself. I'm just copy this program and share in your chat window. Okay. One minute. Okay. Now these things we are done. 3 LED running output. We are done actually. Actually, I have created the GIF images and to show the output actually. Every time actually you can't carry your hardware with you to show the output to your students. So that's why this GIF image will show, it is a very helps to explain you the output. Okay. Now next one is the serial communication. We'll start with the serial communication because before starting the any other sensors, any sensor interfacing, we should know the serial communication first. Okay, so what is serial communication? Serial communication is the way for communication between the two devices serially. Now serially means, actually whatever your data is there, is it 8-bit data or 16-bit data or any 32-bit data, there is only a single line is available. Only single line is available for transmission. If there is only single line is available for transmission, there is no reception line, then that type of communication called as, can anybody answer me? If there is only single line is available for only transmission purpose, there is no reception line is available, then that type of serial communication is called as, it's called the one-way communication. The sender is only sending, the receiver is only receiving. The receiver cannot able to send the data, or sender cannot able to receive the data. So that type of serial communication is called as a simplex communication. It is called as a simplex type of communication, just like your television set. On your television set, actually you are only watching whatever the channels are broadcasting. Okay, so that is a simplex kind of communication. Okay, the next one is the half duplex kind of communication. In a half duplex kind of communication, sender can send the data as well as receive the data, but one at a one time, only one at a time, just like your walkie talkie. Okay, so if you want to talk, you have to press the button. When you're pressing the button, then you can only able to talk, but when you are talking, actually you are not able to receive the data. So that is the kind of your half duplex type of communication. And the third type of, and that we are using in your Arduino, and that is your full duplex communication. In the full duplex type of the communication, actually we can send the data, as well as while sending the data we can also able to receive the data. So we can, the both of the communication we can do at a time. Serial transmission also, serial reception also we can do. Okay, so serial transmission and serial reception. For say a serial transmission and for serial reception, there are the separate line is available, just like your RX and TX line. So if both separate lines are available for this, then that type of communication is called as a full duplex type of communication. Getting? So here serial communication, to start the serial communication, actually in your Arduino, actually it is a very easy. Just you need to mention the baud rate. Now we will discuss about the baud rate. Okay, so before explaining myself, can you tell me what do you mean by baud rate? Okay, there is one again. Notice, requesting all participants to submit the feedback. Afternoon session feedback link is there. You need to submit the feedback. But meanwhile, can you able to tell me what is the meaning of baud rate? You can use the chart window. Here the baud rate is set as a 9600. So what is the meaning of baud rate? If you know, answer it. If you don't know, just type don't know. Yes, correct, very correct. It is called as the speed of the data transmission or the serial communication. It is the number of bits. Yes, again, it is very explanatory. It is a number of bits transfer per second. Yeah, it is very correct. The speed of serial communication is referred in terms of the BPS. The unit of the serial communication is BPS, bits per second. So it means that how many bits you are transferring in a 1 second, that is called as your baud rate. So here the baud rate is nothing but the rate of your communication channel, the speed of your communication channel. Okay, your Arduino is supporting more communication channel, more speed, like your 38400 also it supports. Okay, so but 115, so it support the higher rate also, but meanwhile actually we are stick to the basic one, 9600. Okay, 960 is the standard one. It's very standard. All the serial devices, just like your Bluetooth, your Wi-Fi, all these are, if there are the serial is there, by default they are came with the serial baud rate of 9600. So that's why we start with the serial baud rate with the 9600. So here to start the serial communication, actually we should use the function called as a begin function. The begin function is available in the serial class. It is available into the serial class. Actually serial class is already been written by the Arduino. We have to just call that function. So whatever the things that is required to set the baud rate of 9600, that is timer has to be set. That if you know, if you have studied the embedded system, then you know that what is the things that we have to do to set the baud rate. But here very simple, the front end becomes easier. That is, we need to call here begin function only. The remaining things, the Arduino will handle that. So serial is the class name. In that class, the begin function is there, and we are calling that function with the argument as a 9600. Okay, so and we have to put it only once. So that's why we have to copy it, or we have to write it into the setup function. Getting? Okay. Now, very first program that we are doing for the serial communication is the hello world program. So very simple one. Void setup serial.begin 9600. Okay, so in a setup, actually we are setting the baud rate of the serial communication. Then after that, in a loop function, we are printing the hello world. Now to print to the serial, actually there is a same function, print ln function. Ln, we know that ln is print with the new line, just like your system.out.println available in your Java. Okay, so ln with the new line, hello world with new line. If you only using print, the new line will not be inserted. Okay, so you have to print the hello world at every new line. So that's why use the println function. This function is also available in serial class. So call this serial.println, pass the argument hello world, and then delay we have to produce. Why? Because in between the two print, delay should be there. Okay, if you are not putting the delay, the hello world will be print in infinite time. It is also printing infinite time, but it is printing very fastly it will be printing. So to make the slower rate, we are putting the delay function there. Getting? Now we will try this program. We'll just try the same program on your Arduino. So let me share you the screen of the Arduino. Yes, this is my screen. Okay, so I am creating the new sketch. I'm creating the new sketch here. The new sketch is ready here. Setup. Yeah, in a setup, actually serial dot begin. Make sure that here S is capital, B is small. Serial dot begin 9600. Okay, and in a loop function, actually we have to put serial dot println and then 9600. Okay, not 9600. It should be hello world or hello NHC. And then after that, delay 1000. Control S, I'm pressing Control S, and again I am saving it with the serial underscore NHCE. Okay, done programming, compiling the board, compiling my program. And then uploading the program. Okay, now where to see output? There is no output here. Your LED is also not blinking. So where is it? Because LED programming we have not done. So what? Where is the output? We have to see. We need to go to the tools. We need to go to tools and serial monitor. We have to open. Actually, I have to stop it, and again I have to share the whole desktop. Okay. Now you can see the output here. The hello NHC will be printed here. Continuously hello NHC will be printed for the every 1 second delay. Getting? But make sure that here you have selected the proper baud rate. I have selected the proper baud rate as 9600. No line encoding. This is the setting that we have to do. If you click on the timestamp, then timestamp also there. After exactly actually 1 second, actually you will get the output. Okay, so are you getting this? Now what we can do, we can combine the both program, the blink LED program and the serial communication program, like that. Const integer LED1 is equal to 8. Okay, and then pin mode, then LED1 comma output. Okay, so LED1, that is pin number 8, should be configured as the output purpose. And then now I am doing my blink LED program, so do digital write and then LED1 comma high, LED1 comma high, and then delay, and then digital write LED1 comma low. Okay, now when the LED is on, I am printing LED on, and when LED is off, I'm printing the LED off. Very simple. And delay 1000. So both program I have actually combined. I am uploading this program and let me show you the output. Okay, just open the tools, go to tools and serial monitor. When you go for LED off, LED on, you can see when the LED is on, it will print LED on. When LED is off, it will print LED off. So what are the status is there of the LED, you can see on your serial monitor. Yes. Yeah, Dr. Suma. Actually, I am sharing the morning session feedback link. This is the morning session feedback link. Okay, so are you getting this? Now, this is the way that is you have to make interest in your students, that they have to play with the LED and the serial communication. Now, next one is can we control the LED on or off by using serial communication? For example, if I'm sending small a, the LED should be on. If I'm sending small b, the LED should be off. Okay, can I do this? Yes, can I do this? Yeah, definitely we can do this. So how to do this? Let's see. Okay, so what is the thing that we have to do? We have to see the if there is a serial thing is available or serial data is available or not. So there is a function name as a if serial data is available. Okay, if serial dot available is greater than 0, it means that if there is a serial data is available, more than 0 is available, that is 1 byte, 2 byte, 3 byte, 4 byte, how many bytes are available? If more than 0 byte is available, then it will go inside if statement. If it will go inside the if statement. If it is not available, if the serial data is not available, it will not go inside if statement. Very simple. Okay, so we can check it here. If now we have to read that data, we have to read the data. So for reading the data, we are creating one variable, character variable. Why character variable? Because why character variable? Because whatever the data we are getting, that data size is only 8-bit and the character is also having the size of 8-bit. So we are getting the data, we are putting that received data from the serial into the character data type here. So character ch is equal to serial dot read. Okay, so we have read the character. So character ch equal to serial dot read, and then after that, now this serial dot read is only we are doing when there is a character is available. So I can put it here. If serial data available, then we have to go here and then read the serial data in ch variable. Now we have to compare that ch variable. So comparing, for comparison, we will use if statement or switch case statement. We can use anyone. So if ch equal to small a, if the received data is small a, then what we need to do? We have to on the LED. So how to on the LED? LED 1 comma high. Very simple. Otherwise, simply otherwise, if digital write, if else if ch equal to small b, then LED 1 comma low. Are you getting this thing? What that I have explained with you? If the serial data is available, go inside, read the character and compare the character. If the character is small a, on the LED on. If the received data is small b, then LED off. Getting? Yes, I am compiling this program and let me check the output. Now you can see here the LED is off. Now I am opening the serial monitor. Opening serial monitor. When you open the serial monitor, now to on the LED, what thing I have to send? I have to send small a. So I'm typing the small a here and I'm pressing to the send. When I'm pressing the send, LED is on. Okay, now I want to switch off this LED. How to switch off this LED? Type B and press send. The LED is off. Yes, just try one more time. Small a, LED on. Small b, LED off. What happen if I type G, small g? Can anybody tell me in chat window what happened when I send the small g? Yes, what happened when I send the small g? Error? No, there is no error. Nothing will happen. Nothing will happen because we have not handled that condition. Look at here. We have handled only two conditions, CHA and CHB. We have handled the two condition only, so that's why it will only respond with these two inputs, A and B. It will not respond with the G. Getting? So if you want to respond with the G, then you have to write here. You have to write like else if ch equal to small g, then suppose what we need to do. So I want to switch on the all the LEDs. I want to switch on the all LEDs. LED 1 is high. Likewise, LED 2 and LED 3 should, I have to make it as a high. So digital write LED 1 comma high, LED 2 comma high, LED 3 comma high. But here make sure that you have declared here that LED 2 and LED 3, it is pin number 9 and pin number 10. Also here you also see here the pin LED 2 and LED 3 should be declared as output. Okay, then only your program will run there. Okay, so again compiling. And again opening the serial monitor, and let me show you the output. So small a, LED on, small b, LED off, and small g, all LED on. Okay, small g, all LED on. But when I press small a again, nothing will be happened because we have not written that condition. Small b, only one LED is off, but small g, all LED is on. So you have to manually, you have to put all the conditions there. So what we need to do? Okay, all LED on, all LED off. So this is the very simple program of uh, the same program you can convert to control your home appliances. Okay, home appliances, just like suppose instead of putting the LED, actually you have connected to the home appliances through the relay. Okay, there is a relay is there. Using that relay, actually you can control the high voltage devices by using the low voltage. 5 volt will control the 250 volt. So the relay is there, isolator is there. Okay, so using the relay, actually you can control all this. So by sitting at your computer, just send one, first light will be on, just send 2, second light will be on. So whatever the command that you have decided, that you just have to send, and according to it, actually the particular device will be on. Instead of this writing the if statement, because if statement actually requires a lot of space, you can use the switch case statement. Switch ch for the different cases, like case A. Okay, for case A, we have to put the digital right, then LED 1, comma high, and then break. Okay, like that. Case B, case B is there where LED 1 is low. Like that, you can have the different cases, case C, case D, case D, where the individual LED you can control. LED 1 comma high, LED 2 comma high, LED 2 comma low, LED 3 comma high, LED 3 comma low. Okay, so the remaining program actually you need to do there. This is the today's assignment. So this program I'm putting into your chat window. Okay, so any doubt here? Any doubt until this point? So last half an hour session actually will get for the doubt clearing session. So just can just ask me any question regarding to today's session. Actually, I will answer all the points. Okay, so can we read a text or CSV file data resides in computer drive using the serial communication? Yes, you can read, but one program should be there. Okay, one program should be there in your computer which will respond to the Arduino through the serial port. Okay, so suppose that program can be designed in your Java or C language or C++ or even in a .NET. Okay, so that whenever the Arduino actually requires the data through the serial port, that application will continuously monitor whatever the command that is coming from that Arduino. If the command is the read command, then your application which is on your computer, it will read that particular text file and it will send that data serially. So one third party software or the third software is available. So which is better, Arduino or Raspberry Pi? Both are having the different use. Actually, Arduino is for the simple application and it is a single task application. Only single task application means one program at a time you can run on your Arduino, but in a Raspberry Pi is having the Linux operating system inside it. So you know that what is the benefit of using the operating system, the multitasking system we can design in your Raspberry Pi. So 3, 4 or multiple programs It's concurrently can be run in your Raspberry Pi, but not in the Arduino. So better depending on your application. Next one is, can we access antenna to antenna communication using Arduino and Raspberry Pi? Yeah, you can. But what type of antenna? RF antenna? Yashwant Krishnan sir. RF antenna. Yes, yes. RF to RF antenna. Yeah, I already have done that programs. RF to RF communication directly we can do without the encoder and decoder. We can directly communicate. Okay, two Arduino is communicating with each other through the RF communication. I have already done that program and it is also available. And microchip patch antenna. Actually, I'm not in the microwave, so that's why I am not answer your microchip patch antenna. But if you tell me what is the interface of that antenna, then I can explain you. That is a digital or analog interface. It requires the interface because Arduino cannot understand that. Yeah, digital. If it is digital, then what is the how many bits that microchip antenna is giving data? 10-bit data, 16-bit data, or how much data? If it is 8-bit data, then it is okay, because your Arduino serial port is supporting the 8-bit. Yeah, 8-bit. Then it is definitely just you need to convert that. If the microchip antenna is giving the parallel output, 8-bit parallel output, then you have to convert that 8-bit parallel output to serial, and then we have to feed to your Arduino. Can we use wireless sensor? Yes, we can definitely use wireless sensors very easily. Just like, can you say, tell me one of the example wireless sensors what we are talking about? Srinivasa Gopal. Next question, sir, which protocol is good for Arduino to send data to cloud like AWS, Azure, or Google Cloud? Actually, protocol, which protocol is used? Okay. AWS, Azure, actually I have not go through this AWS and Azure. Generally for academic purpose, for student, we have stick to that ThinkSpeak, and because they are using the simple get and post method. So using the get and post method, actually we can directly dump our data into the cloud. But AWS and Azure I have not seen. But it should be that post method only, because for sending your data, actually you have to make a packet, and that packet have to send. So that packet might be different for the different platform, cloud platform. So Bluetooth enabled sensors or Zigbee Wi-Fi. Yes, yes, yes. Yeah. Any, all the Zigbee also can be interface. Bluetooth also can be interface. Any wireless sensor can be interface. If it is serial, then we can interface. Actually, it is a serial only. Zigbee is also serial. Wi-Fi is also serial. Bluetooth is also serial. Bluetooth HC05. HC05 is the Bluetooth sensor. Zigbee sensor is already there, and the Wi-Fi is a ESP01, which is give the serial output. Can we write digital? No. We cannot write, Subramanya Pal. We cannot write two in LEDs at a one time, because digital write is only taking the two arguments. It is only taking two arguments, so you cannot give the three arguments. I can directly give your demonstration. Okay, so there is an error. Okay, error at digital write uint int. Okay, so what is the prototype of the digital write? Just you can see here, prototype of the digital write is uint 8 uint 8. Okay, so it is only 8-bit integer, it is accepting only. So you cannot write the two LEDs at the same digital, right? Okay. So any other question, any basic question also welcome. Any question in your mind, you can ask me. Okay, so have you filled that attendance? Today's attendance, afternoon session attendance link. Yeah, Gangadhar sir has been shared. This is the, I am also sharing the afternoon session link. Afternoon session. Yeah, feedback, actually feedback session, feedback link is there, but that same link will be treated as an attendance link. Okay, so if you have done actually, so should I stop? Because today's topic is already being covered. Yes, if you're not having any doubts, then I think we should stop here. And sir, for CSC, on which part we should focus, software or hardware? Both. For CSE, we should focus on the software as well as the hardware, because to communicate with the hardware, actually knowing the software is not only important. You should know the behavior of the hardware, that is how the hardware behaves. That if I'm sending 1 to that one, then how it behaves. If I'm sending 0, then how it behaves. So the morning session link. Okay. Okay, for Swati. Okay, so this is the link, morning session link. Okay, software as well as hardware is both important for learning or get into the deep of your IoT. If you see any IoT book, actually, they have focus on the both parts. Actually, IoT is the, for IoT actually, IoT is nothing but the sensors and actuators. We have to make it as an internet enable. But to make the internet enable sensors and actuators, we should know the sensors and actuator behavior. Yeah, this all the session I am recording, and this will be available. All the session will be available on the YouTube. Okay, so today's session is being already, I have uploaded. So this is the link for today's session. Yeah, this is the YouTube. Those who are not able to join the today's morning session due to some network issues, they can refer this link. And after the completion of this session, again within the half an hour, actually, the same link will be available on your WhatsApp group. Okay, so thank you for attending this session. I think all the doubts I have cleared, and we'll meet you tomorrow exactly at 10 o'clock. Okay, thank you. So I'm